Welcome back. It's our topic 1.5, rational numbers. So we can have an idea about what is a rational number. You can have a look at the diagram here. This is a Venn diagram. So you can see that rational number is the outermost, and it's including integers, whole number, counting numbers. And we have also fraction and decimal. That's why rational numbers is equals to any number that can be written as a fraction. Okay, have a look on this. This is the exploration activity. So you can see it, the exploration activity here. You are given some numbers, alright? You can see that you are given some numbers. So there are altogether 6 numbers, and try to check on the numbers. Can we change the numbers given into fraction form? Let's check the first one. 0.3. We can put it as 3 over 10. Negative 1.25. Negative 1.25, what do we get? You can check it with a calculator. Negative 1.25, what do you get for it? You can get it 1 and 1 over 4. Or we can just put it as a negative 5 over 4. Alright, and then 1 and 1 over 3, yes, it is in fraction form, or we change it into improper fraction. You will get it 4 over 3. 5, okay, as we have learned before, 5, which means 5 over 1. Negative 8, still the same, negative 8 over 1, even though it is negative, still we can change it into fraction form. And about negative 2 and 2 over 5, we can change it into improper fraction. 12, negative 12 over 5. So you can actually see it, all the numbers show here. You can change it into a fraction, which is in the form of P over Q. Alright, and P over Q must be integers. So, and this is how we define rational number. So for example, here you have 4 numbers. Okay, you have 4 numbers here, which you have it 1 and 4 over 5, which you can convert it into 9 over 5. 4 over 3 is already in the fraction form. Yep. Okay, and negative 9, which is negative 9 over 1. 3.5, which is 3, and 5 over 10. And we simplify it and we change it into improper fraction. We get it 7 over 2. Okay, so what can you observe here? 9 over 5, 3 over 4, negative 9 over 1, 7 over 2. All of them can be in the form of P over Q. Okay, all of them appear in the form of P over Q. Alright, so you can check it, compare it. There you have it. 9 over 5, 3 over 4. It is in fraction form. This one in fraction form. This one also in fraction form. And the denominator must not be equals to 0. When it is equals to 0, it couldn't be. Alright, you can check it with your calculator. If you put it divide by 0, it will come out as math error. Alright, so impossible for the denominator to be 0. So here your homework 1.5a. This one we discuss in the classroom, and let's check on this 1.5a. So you have it negative 2 over 4. There you have it, negative 2 over 4. And what can you do for that? Check on this. We can simplify it, become negative 1 over 2, right? So the first one, yes, 8 over 7. Yes, it is in fraction form. So negative 1.2 and 1.5. It is not integer, but can we change it into integer? Since the numerator and denominator are both decimal. Makes sense, right? That's why you get it, negative 12 over 15. Possible to be in this format, both up and down. You multiply with 10. Multiply with 10, multiply with 10, and then we get this one. So this one also possible to be rational number. 7.65. 7.65, you change it into fraction. Alright, 7.65, change it into fraction. What do you get? You will get it 7 and I'm write it over here. 7.65 equal to 7 and 13 over 20. 7 and 13 over 20, and then we can actually change it into an improper fraction, which is 153 over 20. So it is in the form of PQ, P over Q, like this format. Alright, so this one is a rational number. How about 2 and 2 over 5? We can change it as well, right? 2 and 2 over 5, we change it into fraction form. It will become 12 over 5. Yep, it is in the form of P over Q. Yes, this is a rational number as well. And negative 4.2. Negative 4.2, which is equals to a negative 4, 2 over 10, and then we can change it into improper fraction. What do we get? Negative 4 and 2 over 10. You change it and then you will get it 21 over 5 when we straight away simplify it. Okay, so it is still in the form of P over Q. Correct. This one is also a rational number. So you could actually see that rational number must appear in the form of P over Q. Okay, must appear in the form of P over Q. If they cannot change it into the form of P over Q, it is not a rational number. Alright, it is not a rational number. So maybe we can have some example, okay, on how to check it is not an rational number. We clear the ink on this slide first. Okay, maybe I can show you some of the example, like okay, so now this is about irrational number. When you talk about irrational number, which means the number that is not a rational number, okay, it cannot be written as the simple fraction. So like the one we learned before about rational number, it can be written in fraction, which is something in the ratio form. That's why we call it rational number. For irrational number, which means we cannot change them into fraction or not in the ratio form. Example like pi, 3.14159, and you can have long number forever, not ending number. Alright, so how about next one? This is a rational number, okay? Just let you to compare rational number and irrational number. Rational number, you can write it in the ratio form. 7, right in that ratio form will be 7 over 1. 0.33 is a rational number as well. Because why? It can be written in the form of 1 over 3. That's why whenever they can change it into the fraction form, P over Q, one number over one number, it is a rational number. Okay, this one is the irrational number. So you can see that the famous example will be pi. Okay, where you have it 3.1419 and the never ending decimal number. That's why you can have it here. This is when we check it in a calculator, it can give you never ending decimal. Alright, so we cannot to write it as a simple fraction that is equals to pi. So pi will be an irrational number. Okay, however, in your form 2 and form 3 level, you may learn about pi when you get in touch with a circle. It is an approximation number. Okay, you still can use it for finding the answer. Okay, and there's another clue is that for irrational number, the decimal goes on forever without repeating. You can see it over here, the number is not repeating. Okay, the decimal is not repeating, so it is an irrational number. Okay, like I mentioned before, it cannot be written it as a fraction. So remember that it is irrational not because it is crazy, okay, because irrational also meaning crazy, but somehow in maths it's not refers to the numbers crazy, but it's mentioned about that the number cannot be written as a ratio or a fraction. That's why we call it irrational number. Alright, so have a look at this one. 1.75, we can change it as a fraction, which is 7 over 4, which means it is a rational number. So 0.01, you can change it into fraction, which is 1 over 1000. It is a rational number too. How about square root of 2? Square root of 2, you can check it with your calculator. Square root of 2, you may get still a lot of decimal numbers. 1.142135562 and so on. So you cannot change it into the simple fraction. So it is an irrational number here. Alright, get the idea of irrational number. That's why you have it square root. Square root we'll learn about in details in our chapter 3 later on. Thus you get it. There's of square root 2 is a 1.142n, etc. No ending. That's why we cannot change it into simple fraction. It is an irrational number. Alright? So these are some of the famous irrational number. One of it will be pi. The other one will be Euler numbers. Okay. Another one will be golden ratio. And this is a square root. Okay. However, not all square root are irrational. Okay. Not all square root are irrational. Most of the, you can check it over here. The square root, when you get a never-ending decimal, it will be an irrational number. However, there are some rational square root. Where you get it here? Square root 4, you can get your answer is 2, which is a rational number. Square root of 9, you will get 3, which is a rational number as well. So have a look on this one. Square root 2 over 5. Press into your calculator. Square root 2 over 5. What do you get? Square root 2 over 5. You will get something like 0. Let me change it. Yep, you will get it as 0.632455 32 and so on. Okay, so when you see that the decimal is never repeat and never ending, so it is rational or irrational. It's supposed to be a irrational number. However, you check on the other one, square root 16 over 25, where you will get it 4 over 5. So it is in the form of P over Q. It is a rational number. So you can see that this is a difference. I hope that you get an idea about rational number. Next, we will move on to combine operation, where we're going to combine integer, fractions, and decimal. Here is the combine operation. We need to go back to our basic concept, which is the BODMAS concept. Alright, the BODMAS concept here. We need to solve the one inside the bracket, and then if there is order, we're going to do the one with order, and then division, multiplication, and the next one to addition and subtraction. So look at example 1. Here you have the decimal and your fraction. I would suggest to change all of them into fraction, easier for you to do later. Alright, so negative 0.4, which is negative 4 over 10, and then you already converted it into fraction. There you have it plus, there you have it multiply. We're going to solve the one with multiplication. There you have it, negative 3 over 16 plus with this. Change it to the same denominator, and you were able to get the final answer. Alright, just to remind you on the decimal, you're going to change it into fraction, and then you'll repeat the step that we learned before in the BODMAS concept. Same go with your question B. 18 multiplied with 97 over 12 plus with 1.5 divided by 0.3. Change the decimal into fraction. Okay, so you have done the first step to change it into the fraction. Next, we're going to do it for bracket. Where's your bracket? Yep, you see the square bracket over here, square bracket over here. Alright, so we're going to solve the one inside the bracket. You have 3 numbers, 1, 2, and 3. So check on this. This is multiply, this is plus. Back to BODMAS, you can solve the one with multiplication, and then you solve the first two. Okay, with multiplication, you get negative 21 over 2, plus with 3 over 2. Okay, you solve the one inside the bracket. There you get a negative 18 over 2, divide by fraction. Don't forget, when you see divide by fraction, change it into multiply, upside down, and then you will get the answer. Alright, so I hope that this one should be alright for you, since we have learned about fraction. Just to add one more step about combine operation with fraction, decimal, and integers, you need to change the decimal into a fraction. Okay, so this one will be your homework. Self practice 1.5b. You're going to complete it and explore it, see how you can apply what you have learned. That's all for today. See you guys. Complete the homework. Bye.